Welcome! In this lesson, we're going to be learning about factoring by grouping for polynomial functions. We can use factoring by grouping when there are 4 terms to be factored. We do need exactly 4 terms. We're going to arrange the terms so the first 2 have a common factor and the second 2 have a common factor. You don't have to change the arrangement of the equation as it's given unless you want to. So you can just go with the way they're arranged, and that's what I usually do. For each pair of terms, you use the distributive property to factor out the pair's greatest common factor and put the leftovers in parentheses. If there's now a common binomial factor, factor it out. If there's no common binomial factor, begin again or try a new method. Often you'll need to factor one of your binomials. So after you factor, you're going to have one of those binomials is going to need to be factored again. If no rearrangement leads to a common binomial factor, then the polynomial cannot be factored using factoring by grouping. Right? So in many ways, the steps are the same as factor by grouping for quadratics, except we don't have to figure out the 4 terms we had before somebody added them together, right? Because we don't have any like terms that disappear on us, right? Because they're combined. The 2 terms are combined. Right? So we don't have to get back to our 4 terms. We have our 4 terms. The other difference is sometimes we'll need to factor again. All right? So that's a couple of the differences there. Let's see what it looks like. And you'll see that factor by grouping is really a nice method to work with. All right, so we have x cubed plus 2x squared minus 9x minus 18. Our equation is degree 3, right, because we have an x cubed. So we're expecting 3 solutions. All right, so we're going to use factor by grouping. And I like the arrangement just the way it is. You're going to see I'm not going to change any of them. So unless something doesn't work, we're not going to change it. X cubed plus 2x squared, they're going to be a group. Make sure this is a plus. And then negative 9x minus 18. You want negatives to go with the term, right? Otherwise, you may distribute a negative that you didn't mean to. All right, so now we're going to pull out a greatest common factor. So from x cubed and 2x squared, that's going to be x squared. Right? They both have an x, and they both have an x raised to the 2nd power. All right, so x cubed divided by x squared, that's going to be an x. 2x squared divided by x squared, that's going to be a 2. Negative 9x and negative 18, greatest common factor, is going to be a negative 9, right? Because we want our x term to be positive. So it matches the x plus 2. Negative 9x divided by negative 9, that's a positive x. Negative 18 divided by negative 9 is a positive 2. Right? And so now we can factor out that x plus 2. And we're left with the leftovers, x squared minus 9. So we literally just factored out an x plus 2 from both of those terms, and the leftover term, right, would be combined, right, because we'd have an x squared and we'd have a negative 9 all multiplied by an x plus 2. Right, so we're not done factoring because we don't have all linear factors. We have a square, right, and that's a difference of squares, which means that can be factored. So let's factor the difference of squares. So we have x squared minus 9. Right? So our a is 1, our b is 0 because there is no x term, and the c is negative 9. So 1 times negative 9 is negative 9. We need 2 numbers that multiply to give us negative 9 and add to give us our b term of 0. Well, those are going to be negative 3 and positive 3. Right, and I'm going to replace that 0x with a negative 3x and a positive 3x. And of course, we keep the first and last terms. So here we have to come up with the 4 terms. Right? And so here we needed 2 more because we replaced a 0 with a negative 3 and a positive 3. And the first 2 become a group and the second 2 become a group. So now it's just like the factoring for polynomials. And our greatest common factor is an x. If we divide both of those by x, we have an x minus 3. Our greatest common factor for 3x and negative 9 is a 3. If we divide both of those by 3, we have an x minus 3. Make sure you do follow the steps for factor by grouping, right? You don't want to say anything that's untrue. All right, so now we can factor out that repeating x minus 3, and then we have the leftovers, x plus 3. All right, and actually I'll just put the equals 0 later. Down here, where we're going to solve. All right, so now we're going to take all three of our factors. We have the x plus 2 from step 1, and the x minus 3, and x plus 3 from step 2. We'll set them all equal to 0 to solve, and we'll have our three solutions. So if x plus 2 equals 0, we'll subtract 2 from both sides, x equals negative 2. If x minus 3 is 0, we'll add 3 to both sides, x is equal to 3. And if x plus 3 is equal to 0, we will subtract 3 from both sides, so x equals negative 3. And there you have it. We have found our three solutions in under 5 minutes. And you can probably do it faster because you won't be talking the whole time. All right, so these are our steps. We're going to use factor by grouping. If we have a binomial that can be factored, in other words, it's a difference of squares. So we can always factor a difference of squares. Okay? And once we have our factors, we're going to set our factors equal to 0 and solve. All right, so now we have another one. Right, and this again is degree 3 because we have an x cubed. Right, and so we're expecting 3 solutions. Right, so our first step is to do factor by grouping. Right, so the first two are going to be a group, the x cubed plus 2x squared, and then the second two are going to be a group. Don't forget your plus, negative x minus 2. All right, so we could factor out an x squared. They're both divisible by x squared. X cubed divided by x squared is x. 2x squared divided by x squared is 2. Negative x and negative 2, we could factor out a negative 1. Right, because we want x plus 2. Right, negative x divided by negative 1 is x, and negative 2 divided by negative 1 is positive 2. So we have a repeating factor. We'll factor out that repeating factor. And we're left with a something squared, which we need to solve. This something squared is a difference of squares, and that can be factored. We would have to use a different solving technique had that been a sum of squares. All right, so we have x squared minus 1 multiplies to give us, so 1 times, or let me write a, b, and c first. A is 1, b is 0, and c is negative 1. So 1 times negative 1 gives us negative 1, and our b term is 0. Two numbers that multiply to give us negative 1 add to give us 0. Why, of course, they're negative 1 and positive 1. Let me just trying to move. There we go. Oh, I guess I can't. My negative 1 there is almost on top of my a. All right, so we will replace that 0x with a negative x and a positive x. The first two are a group, the second two are a group. Greatest common factor for x squared and negative x is an x. Divide both of those by x, and we have x minus 1. Greatest common factor for x minus 1 is 1. And of course, it won't change if you divide it by 1. We'll factor out that repeating x minus 1, and then the other factor is the leftover terms, x plus 1. Our final step is to set all of our factors equal to 0. So we have the x plus 2 from before, from step 1, and then we have an x minus 1 and an x plus 1. All right, so if x plus 2 is equal to 0, subtract 2 from both sides, x is negative 2. If x minus 1 is equal to 0, add 1 to both sides, x is 1. And if x plus 1 is equal to 0, subtract 1 from both sides, x is equal to negative 1. And another one solved. Okay. All right, so here we have not degree 3, but degree 4. We have an x to the 4th, and we have another step 1. So factor out the greatest common factor. We have a greatest common factor to factor out before we do anything else. Notice that every one of those terms is divisible by an x. So let's factor that out first. Right, so if we divide x to the fourth by x, we have x cubed. Negative 2x cubed divided by x is a negative 2x squared. Negative 16x squared divided by x is a negative 16x. And 32x divided by x is 32. All right, so now we're going to use factor by grouping with this part only. And the first two become a group, x cubed minus 2x squared. And the second two become a group. I always, if it even looks like factor by grouping is a possibility, I always try factor by grouping. It is our easiest solving technique for polynomials. And if it doesn't work, you'll figure it out really, really quick. All right, so our greatest common factor for x cubed and negative 2x squared would be an x squared. We'll divide both of those by x squared. We have x minus 2. Greatest common factor for negative 16x and positive 32, well, that would be negative 16. Negative 16x divided by negative 16 is x. 32 divided by negative 16 is a negative 2. I was thinking negative 2. There we go. We'll factor out our repeating x minus 2, and we're left with the two terms that they're multiplied by, x squared minus 16. We're not done, of course, because we have a squared term. This is a difference of squares, right? They're both perfect squares, so we can factor that. We have x squared minus 16. Our a is 1, our b is 0, because there's no x term, and c is negative 16. 1 times negative 16 is negative 16. So we need two numbers that multiply to give us negative 16, but add to give us 0. Of course, they have to be opposites, negative 4 and positive 4. All right, so we're going to keep the x squared, of course, and we'll replace that 0x with a negative 4x and a positive 4x. And that gives us our four terms so that we can do factor by grouping. Notice I haven't changed the value of anything. At each step, I have equivalent statements. They may look a little different, but they are always equivalent statements. You have to really make sure that you always have equivalent statements. Otherwise, you have what's called a linkage error, and you have something untrue. X squared minus 4x is divisible by x. I have to make sure I divide both those terms by x, all right? Otherwise, I would be saying something untrue. So x minus 4, right? So notice that x squared minus 4x and x times x minus 4 have the same value. From 4x and negative 16, I can factor out a 4. And if I divide both of those by 4, I have x minus 4. And I don't have a lot of space, but I'll try and squeeze this in. All right, so we have our repeating x minus 4. And then we have the leftovers, x plus 4. Okay, squeezed in there. Yeah, I just didn't use the space well. And let me just do that. Move everybody up just a smidge. Not you. You. There we go. There we can see our little factors. All right, our last step here is to set all our factors equal to 0 and solve. Now don't forget anybody along the way. We factored out an x, then we have an x minus 2. We factored the difference of squares, and we have x minus 4 and x plus 4. Always go back to the degree and make sure you have as many terms, right, as the degree. So we have x times x minus 2 times x minus 4 times x plus 4 equals 0. So by the way, our original equation, x to the fourth minus 2x cubed minus 16x squared plus 32x, has the exact same value as x times x minus 2 times x minus 4 times x plus 4. It's in factored form, but it's the same, it represents the same equation. So we're going to set all of our factors equal to 0. We have x equals 0, and that's just about the end of that, right? X minus 2 is 0, add 2 to both sides, x is 2. X minus 4 is 0, add 4 to both sides, x is 4. And then finally, x plus 4 is 0, subtract 4 from both sides, x is negative 4, and we are done. And that is it. And we have our solutions, except one of them is really crammed in there. And so I'm going to write it just a little neater. X plus 4 equals 0. And we subtracted 4, x is negative 4. That looks a teeny bit better. All right, so we've done another problem. And this one involved our earlier lesson, which was factoring out a greatest common factor. Okay. All right, so let's take a look at this one. Also has a greatest common factor. Right, so we have degree 4, because we're in x to the 4th, right, and we're expecting 4 solutions. Right, so we're factoring out the greatest common factor, which is, so notice they're all even numbers, which means they're divisible by 2. Actually, I'm going to write it on this one. I should have on the last one. The last one, the GCF, was just, I think, an x, yes. GCF equals x. Here, it's a 2x. Right, so we'll factor out the 2x, and we'll have an x cubed. 8x cubed divided by 2x, that would give us a 4x squared. Negative 18x squared divided by 2x is a negative 9x. And negative 72x divided by 2x, that would be negative 36. All right, so now we'll do factor by grouping with the leftovers here. So we have x cubed plus 4x squared minus 9x. Actually, let me write the parentheses in right as I go. X cubed plus 4x squared, you're a group, plus negative 9x, negative 9x minus 36 equals 0. So by the way, you can even see that they have common factors. So that even kind of tells you that factor by grouping might be a good choice. X cubed and 4x squared have a common factor, negative 9x and negative 36 have a common factor. There's a pattern to this. Right? And that I think is pretty apparent. So we'll factor out the x squared, and we're left with an x plus 4, and we'll factor out a negative 9, and we'll be left with negative 9x divided by negative 9, of course it's x, negative 36 divided by negative 9, and it's 4. We'll factor out our repeating x plus 4, and then we have the leftovers, x squared minus 9. Of course, we're not done because we have a squared term, and we need to factor that. So difference of squares you can factor. We'll talk about what to do if you have a sum of squares. So x squared minus 9. So our a is 1, our b is 0, c is negative 9. All right, so 1 times negative 9 is negative 9. Multiplies to give us negative 9, adds to give us 0. Of course, it's negative 3 and 3. Now, have we factored x squared minus 9 already? I moved too quickly to the left, and I nearly tripped. Let's see. There was a 1. There was a 9. All right, so we have already factored x squared minus 9 in this exact lesson. And so rather than doing it again, we can see it's going to be an x minus 3 times x plus 4. Right? No real mystery here. It's going to get the exact same thing we have over here. So let us just take our x squared minus 9 and write the factors underneath it. X minus 3, x plus 3. All right? We're not going to factor that again. We've already done that once today. This says factors. So we'll set our factors equal to 0. Don't forget, you've got a 2x there. You've got the x plus 4 here, and then the x minus 3 and x plus 3. So we have 2x times x plus 4 times x minus 3 times x plus 3 equals 0. So we have 2x is 0. Divide both sides by 2. It's still 0. X plus 4 equals 0. Subtract 4 from both sides. X is negative 4. X minus 3 equals 0. Add 3 to both sides. X is 3. And x plus 3 is 0. Subtract 3 from both sides. And x is negative 3. Oh, I knew it. I'm trying not to hit that extended page, but I knew it was going to happen at some point. Happened 4 times there. And so let's go from that little teeny tiny writing that you probably cannot read back to normal sized. All right, so let's see if I can squeeze it in there. X equals negative 3. Man, there we go. We've got the 3 in. Let's go back and let's make that normal sized again. There we go. All right, so there you can see all of our solutions, our 4 solutions, right? And degree 4, we're feeling pretty good because we have 4 solutions. All right? All right, so let's talk about factoring and difference of squares. All right, so maybe you have seen a pattern with our difference of squares, and we're going to take advantage of that pattern. So x squared minus 9 factors to x minus 3x plus 3. X squared minus 16 factors to x minus 4x plus 4. X squared minus 1 factors to x minus 1x plus 1. Do you see the pattern? Well, if you don't see the pattern, I'm going to tell you the pattern. But maybe you see the pattern already. All right, so a difference of squares. Difference of squares is any time you have perfect square minus perfect square. Right? There has to be a subtraction, and it has to be a perfect square. X squared, that is a perfect square. 9, that is a perfect square. It is always going to factor to square root minus square root. So square root of x squared is x. Square root of 9 is 3. And square root plus square root. It will always factor that way. Notice that we have two different signs on our 3's there, on our square roots. That's what causes the x term, our b term, to cancel out, because we have a negative 3x and a positive 3x. Right? So it has to be opposites, right? And to do that, we have to have perfect squares. So it's just square root minus square root plus square root. There you go. It also works if there's a coefficient, so long as it follows the pattern. Perfect square, including the coefficient, got to be subtraction, and then perfect square. All right? And that one's going to be a constant. All right? Although it doesn't have to be. I could have like a y squared there, and I could factor that as well. In our case, it will be a constant. So square root of 9x squared, that's going to be 3x. Right? Take square root of 9, square root of x squared. And the square root of 100, that's 10. So you're going to have 3x minus 10 and 3x plus 10. So there you go. You don't need to show me steps anymore on factoring a difference of squares. I've shown you a pattern. All right? And you may use the pattern. Right? That one follows a specific pattern. All right? And that's really helpful with this because you often end up with a difference of squares. Now, actually, before I stop this Nearpod, I want to talk about what would happen if we didn't have a difference of squares, if we had a sum of squares. So let's do one more. It's not in your notes. You might want to add it because I probably should have done one like this. All right, so what if we have the equation x squared, x cubed, excuse me, x cubed plus 2x squared plus x plus 2. And do all pluses here. All right, and we're going to solve for this one. All right, so step 1, we're going to do factor by grouping. So this one's not in your notes, but I really think you should put it in there. Might be a homework problem like this. All right, so we're going to do factor by grouping. All right, so we're going to have first 2 be a group, second 2 be a group, and then next 2 be a group. First 2 be a group, second 2 be a group. There is no other 2 to be a group. We got carried away there. All right, so we'll plot our greatest common factor. All right, so we factor out an x squared, right? And if we do that, we're going to be left with an x, and then, because x cubed divided by x squared is x, and 2x squared divided by x squared is 2. What can we factor out of an x and a 2? Well, just 1. Right? And, of course, you divide anything by 1, it's still the same thing. We have a repeating, x plus 2. And then our leftovers, when we factor out the x plus 2, is x squared plus 1. Now, we're not done because we have a squared something. But we're not going to be factoring a difference of squares. That's not a difference of squares. That's a sum of squares. So if you have a sum of squares, your step 2 is going to be solved by square roots. I would prefer you not solve by square roots if it is a difference of squares. I just showed you how to factor a difference of squares, right? It's so easy, just write that down. The reason I say that is you will make less errors than if you're solving by square roots. And I'll tell you why. However, for a sum of square roots, it's not a factorable. So you're going to have to solve by square roots. Sum of square roots. All right, so for x squared plus 1, all right, I can't factor that. We're going to solve by taking a square root. So you're going to subtract 1 from both sides, so you have x squared is equal to negative 1. Now, the reason I say that you'll make more errors with solving by square roots and reserve that when that is your only technique is because so many of you forget to do this, plus or minus. You forget. It's a square. You've got to have 2 solutions. Somebody this year, because it happens every year, is going to forget the plus or minus and lose a solution and lose points. Right? So reserve this technique for when you don't have another technique, like a sum of squares. So now I have x is equal to square root of negative 1. Of course, that is I. All right, so we have to have 3 solutions, right? This is degree 3. 3 solutions. And here's our 3 solutions, right? I'll just put them down here. Step 3. Oops. Actually, I have no space over here. Let's do it over here. Step 3, solve. Right? So the 2 solutions, by the way, refers to the x squared part. Our 3 solutions are, don't forget him, x plus 2. So we have x plus 2 equals 0, x equals negative 2, and then we have 2 more. X equals I, and x equals negative I. Now I'm going to ask you a question because we'll see this in our next series of lessons, which is graphing. How many x-intercepts does this function have? That's the $64 million question of the day. How many x-intercepts? Right? So in your head, decide. Is it 1? Is it 2? Is it, 3? Or, if I had to put D here, is it none? All right, 1, 2, 3, or 0. Okay, get your answers. All right, got your answer in your head? If you need more time, pause the tape. All right, got your answer? The answer is 1. It has 1 x-intercept, right? Because it has 1 real solution, right? So the other ones, it has 3 solutions, only 1's real, so only 1 x-intercept. The other ones will have an effect, though, on our graph, and we'll see that in later lessons, and I'll show you that effect. But this only has 1 x-intercept, 3 solutions. All right, so difference of squares, you factor, and I showed you the handy-dandy pattern. Easy, cheesy, lemon squeezy. If you have a sum of squares, solve by square roots, right? Because you don't have any other technique. And that's the end of my Nearpod. And so you've learned a whole lot about solving by factor by grouping for polynomials. This is a little whiteboard practice I'll post. And while I have it up here, I'll explain it. Left-hand side, greatest common factor, use that technique. Right-hand side, factor by grouping. Right? So a little practice on both of those techniques. Thanks for watching. Bye for now.